Hello dear students, everyone good morning, pleasant morning. Yeah, welcome to Infinity Learn by Sri Chaitanya. Right dear students, so we have been, you see, in the series 60 minutes into 10 sessions is 60 marks in mathematics JEE 2025. Right dear students, here I am in this session to help you to score easily in JEE Main mathematics. So dear students, you know well, you see, we have been doing the analysis of each and every topic, especially subtopic wise. If we go from which subtopic we got most number of questions in PYQs. Now in this particular session we are going to see about matrices and determinants together. Actually in books generally we find matrices and determinants, both the topics, in a different kind of chapters, two separate chapters, and here we are doing these two together because almost they are interlinked dear students. Right dear students, shall we go to the analysis part? Yeah, you see in PYQs from matrices and determinants together from 2010 to 2024, in the 14 years we got 218 questions. So in an average you can expect 2 questions from matrices determinants in mains. 2 questions, sometimes 1 but sometimes 2. There will be generally 2 questions we can expect from this area. In an average 1.5 question also we can say, maybe some question is mixed with some other concept also. Right, so here you see I have divided the topics or questions into various categories. You see first one, in exclusive matrices, induction based questions. Second, you see there are 22 questions, you can see here 22 questions are there, induction based one. Yeah, out of 218. So whereas algebra of matrices 19 questions, number of matrices 13 questions, transpose related 14 questions, symmetric skew symmetric related questions 7%, and inverse trigonometry 4%. Inverse function, I mean to say the problems related to inverse of a matrix. Up to here percentage is given 31, 26, 18, 14. Then dear students, in determinants exclusively, exclusive determinant related problems, there are 39 questions, exclusive determinant related questions. Then adjoint A, properties of adjoint A, det A and A inverse properties and all these things together, you can see 46 questions dear students. 46 questions means this is definitely very important area in this chapter. That means you need to take much time for practicing properties of determinants, properties of adjoint, properties of inverse and all these things. Then coming to system of linear equations, we can say system homogeneous equations we got only 12, whereas non-homogeneous system of equations 49 questions dear friends, 49 questions. That means of this 25% of the questions out of 218, we can say almost 23% of the questions are from system of equations, especially non-homogeneous dear students. In non-homogeneous also infinitely many solutions case appeared many a times. So this is all to give the insight that dear students, so from which model most of the questions are coming. And do remember dear student, to score the best one in mains as well as advanced, matrices and determinants is one of the most important topics dear students. Now if you see the chart here, you can see most of the questions are taken by, you see this is system of equations and you can say almost properties of determinants and adjoint of the matrix. So in this way the questions are distributed over the chapter dear students. Now I mean to say matrices related important properties, important points, almost nothing, you know how to add, subtract, multiply two matrices, and you know simple special properties related to matrix multiplication. That is, in matrix multiplication AB and BA need not be same, but matrix multiplication follows associative law, and product of two matrices is 0 doesn't guarantee either A is 0 or B is 0. So it doesn't imply that A is equal to 0 or B is equal to 0. There may be cases where A, B both non-zero but the product may be 0. and most importantly, since commutative property is not there, so a plus b whole square in matrices, you cannot write like a square plus 2ab plus b square. You need to multiply a plus b into a plus b. So you just apply transitive law, so that you will get this will be a square plus ab plus ba plus b square. Okay, this is what related to algebra of matrices, simple multiplications, additions and all these things, right dear students. Now I can say, dear students, coming to the questions related to first concept, so induction based questions, I separated these questions. Induction based question means a simple matrix will be given, you may be asked to find a power 30, a power 50 kind of questions. Higher powers will be, you need to find a square, a cube, a power 4, and you need to observe accordingly. You have to guess what a is going to be. For example, for your information, let me take this question here. You see, a is given half of 1 by 2 root 3 this. See dear student, this is a special matrix, all of you know, this is 1 by 2 root 3 by 2 minus root 3 by 2 1 by 2. This matrix is like cos theta sin theta minus sin theta cos theta, right dear students. I think all of you know, let me call it as a theta, my dear friends. What is the speciality of this matrix? For this matrix, a theta into a alpha will become a theta plus alpha. That is the beauty of this matrix, and moreover a theta whole power n will become a n theta. Okay, so this becomes a n theta, its determinant is 1, its transpose is its inverse itself, right. So that is the point. Now for this matrix, he is talking about a30, a25, I relation. A30, a power 30 will become, dear students, you can say here the given matrix, you can write a. So what is this? Cos becomes 1 by 2 means pi by 3. This is a pi by 3, in fact it is. A power 30 will become, you see, a power 30 into pi by 3, which is a 10 pi. A 10 pi means you can treat like 0. So cos 0 1, sin 0 0 1. A power 30 is I, my dear friends. So here in the options a power 30 is I, you just find a power 25. A power 25 will become a 25 into pi by 6. Pi by 6 means 24 will become, so 4 pi plus pi by 6, it is just nothing but a pi by 6, which is nothing but a itself. So a 25 is a. Now you see the options. You see a 25, if it is a, you see this option, a 30 is I, a 25 minus a get cancelled. So option C will be the right answer. When generally we see a power 30, it seems to be very difficult. How can I multiply this matrix 30 times? You no need to multiply, you need to observe certain things, and accordingly you need to find higher powers of a. These problems we call it as induction based problems. The next, my dear friends, you see this question here, 1 0 0 1 is a triangular matrix kind. P power 50 he asked. These are all previous year questions, dear students. If P power 50 in the sense, you see 1 0 1 by 2 1 is a, you try to find a square. So do remember, my dear friends, if you multiply two matrices, especially of this kind triangular, you will get here these two will be 0 only, you will get the same. If you want, you can multiply this element. I want 1 by 2 plus 1 by 2 will become 1. This is a p square, my dear friends. Okay, you just find p cube and you see what happens. P square is 1 0 1 1 into p is 1 0 1 by 2 1. If you multiply here again, you will get 1 0 1 only. This element, if you multiply 1 by 2 plus 1 by 2, 3 by 2 you will get. That means p power 1 you got 1 by 2 here, p square you got 2 into 1 by 2, p cube you got 3 into 1 by 2. You can guess p power n, not guess, you can observe. This is n into 1 by 2, n by 2 here. So dear friends, p power 50 will become here 25 you will get. So 1 25 0 1, option A is the right answer. Just observation based questions. So you no need to calculate p power 50. Observe p square, p cube, p power 4. Accordingly you write this, you solve the questions, dear students, right? Then dear students, you see this question, this is a very easy question even. See, this is also of the same kind of matrix P. If you just find, he wants to write Q is equal to P power 5 plus I. Okay, if it is P power 5 plus I, then in the matrix Q, 2 1 element, 3 1 element by 3 2 element he is asking. So you need to find P square P power 5 first, then let us add I. So P power 5 in the sense, dear students, if you just find P square, that is 1 0 0 3 1 0, this is 9 3 1. If you multiply with the same 1 0 0, here 1 0, here 1, 3 9 3, you just see what happens. This is going to be, since it is kind of lower triangular matrix, here you will get 1 1 1 0 0 0 only. If you want, you can just multiply and see. Next, this element, if you just multiply 3 plus 3, 6 it is. Similarly, you will get 6 here. This element 9 plus 9 plus 9, 27. This is P square, dear students, right? Again, if you find P power 4, means you have to multiply this with the same 1 0 0, 6 1 0, 27 6 1. So you will get here 1 1 1 0 0 0 only. Next element, you see second row first column, 6 plus 6, that is 12. So here also 12 you will get. The next, this element 27 plus 36 plus 27, 54 plus 36, that is 90 it is going to be. P power 4 he is 90. Now you need to find P power 5, multiply this with 1 0 0, here this is 3 1 0, this is 9 3 0. You just multiply, dear students, you will get here P power 5, 1 0 0, here 0, here 1. This element you see, first row first column, 12 plus 3, 15 here, here also 15. So next, this element 90 plus 36 plus 9, 90 plus 36 plus 9, 135, 135 here. This is nothing but P power 5. Now when it is added to I, here plus 1, here plus 1, here plus 1 takes place. That's it. Now this is Q element, 2 1 element is 15, 3 1 element is 135, which is 150 by 3 2 element is 15. So you are going to get 10, my dear friends. That's all. So this is all based on observation. If you don't have that observation, the problem becomes very lengthy, dear students. So such questions are called induction based questions. We have seen such questions in matrices, right, dear student? Then algebra of matrices, in the sense, you know, addition, subtraction, multiplication of matrices and all. Let us take some questions on this model also. You see, dear students, given alpha beta be the real numbers, considering a 3 by 3 matrix such that a square is equal to 3a plus alpha I. This is the relation given. He has, if a power 4 is 21a plus beta I, find alpha beta, he is asking here. So a power 4 relation is given. So you want a relation connecting a power 4. What can we do? You multiply both sides with a, so that a cube is equal to 3a square plus alpha a you will get. Here you replace a square with 3a plus alpha I plus alpha a, so that you will get 9a, 9 plus alpha into a plus 3 alpha I it is, right. Then again a power 4 I want, multiply both sides with a, so this becomes a power 4, this is 9 plus alpha into, this becomes a square, which is 3a plus alpha I plus this is 3 alpha a. Now a coefficient, you see, 27 plus 3 alpha plus 3 alpha into a plus I coefficient 9 plus alpha, this is 9 alpha plus alpha square into I. This is what a power 4, which is given as 21a plus beta I. This is given as 21. So 6 alpha will become minus 6. Alpha value is minus 1. If alpha is minus 1, I coefficient is beta. That is minus 9 plus 1 is beta. That is minus 8 is beta. Beta is minus 8. with this simple calculations observation, dear students, you are going to get alpha minus 1 beta minus 8. So option D is the right answer. So just what you need to do is some little algebra related to matrices, right? Next you see this question, dear students. A, B are two non-zero matrix of n by n order such that A square plus B is equal to A square B. Then you see, dear students, you can write this relation like A square B minus A square minus B equal to 0. It is like xy minus x minus y. So better you add I here and I here. Can I write it as A square minus I into this is B minus I equal to I? Can I write? Yes, you see, because it is like xy minus x minus y plus 1 kind of, x minus 1 into y minus 1 we can write. Do remember, my dear friends, if the product of two matrices PQ is I, QP must also be I. If PQ is I, QP must also be I. So you can write this like B minus I into this is A square minus I is also I. So this becomes B A square minus B minus A square plus I is equal to I. So you can cancel I, you will get B A square is equal to B plus A square. You see, here you got B plus A square is A square B. A square B is equal to B A square. So we can go with option D. Suppose from this step, dear students, I mean to say, yeah, if product of these two is I, you can't say that one of the matrices is I. That's what he said. Yeah, I mean to say you can do this question like this, dear students. Okay, fine. The next, dear students, so this is one kind of algebra related questions. Then number of matrices related questions. So number of matrices means a little bit of permutations and combination based. You see, these questions are also important. We have segregated such questions. The number of square matrices of order 5 by 5, okay, such that, you see, what can you say, with entries from the set 0 and 1, such that the sum of all the elements in each row and the sum of all the elements in each column is 1. That means when you see any row or any column, you must find only one, remaining are all zeros. Suppose first row there are 5 places, somewhere you put 1, somewhere you put 1. So in how many ways you can put? You can put in 5 ways. Suppose you have kept here, that means this column and this row are gone, right? Next, second row I want to put 1. So for the second case, you have 4 possibilities here. So this can be filled in 4 ways. Suppose you have filled here, this row and this column is gone. Then you are left with 1, 2, 3 places. Third one you can put in one of the 3 places. The next second one, first one. Like this you can put 1 in any of the rows. So maybe each row there must be 1, 1. Automatically that belongs to the column also. So automatically the answer must be 5 factorial 120 is the answer, dear students. Okay. The next, you see this, yeah. So the number of matrices of order 3 by 3 whose entries are either 0 or 1 such that sum of all the entries is a prime number. You see, so there is a 3 by 3 matrix which is having 9 elements and sum of all the entries must be 0 or 1 only, no other element, fine. So sum of all the entries must be prime number. So maximum it can have some 9, minimum 0. So prime number means sum can be 2, 3, 5, 7, that's it. Sum 2 means somewhere there must be 2 ones, remaining all zeros. So 7 zeros, 2 ones you can arrange in actually 9 factorial by 2 factorial into 7 factorial, or else I can simply say 9C2. Out of 9 you select 2 places, there you put 2 ones, remaining are all zeros. Similarly, sum 3 means 3 places, 1 should be 9C3 case, and you can take 9C5 and 9C7. This sum will give you the answer for this question. That's it, dear students. Clear? Simple questions. Simple applications of permutations can also be given in matrices, dear students. Next, you see the number of symmetric matrices of order 3 with all the entries from 0 to 9. Symmetric matrix of order 3 by 3. Symmetric matrix means, you know, here the entries can be any, whatever Aij is here, Aji must also be the same. For symmetric matrix, a 3 by 3 matrix, if you fix these 6 elements enough, these 3 are automatically fixed. In how many ways this can be filled? You can fill with any of the 10 digits. This can be filled in 10 ways, this can be filled in 10 ways, this can be filled in 10 ways. He said repetitions are allowed. Even this also, all together you can fill these 6 digits in 10 power 6 ways. So whatever is filled here, you have to write the same. So this can be filled in only one way, because the matrix must be a symmetric matrix. The answer must be 10 power 6, dear students. That's all. Okay. Next, dear students, you see this question. It is an important one, very important one. Recently we have seen in advanced exam also, and 2 times it is repeated in mains also. Let S be the set containing all the 3 by 3 matrices with entries -1, 0, 1. You see, in the matrix the entries must be only these 3 elements, -1, 0, 1. The total number of matrices A, 3 by 3 matrices A, such that the sum of all the diagonal elements of A transpose into A is 6. For your kind information, dear friends, sum of all the diagonal elements of A transpose into A is very important term. You see, suppose if you take A, B, C, D, E, F, G, H, I, some matrix, take its transpose A, B, C here, D, E, F, G, H, I. Now the product will have diagonal entries A square plus B square plus C square, first row first column. Second row second column, D square plus E square plus F square. Third row third column, G square plus H square plus I square. So you observe one point, that the trace of A transpose into A is nothing but sum of the squares of all the entries of the matrix. Let me repeat, the trace of the matrix A transpose into A is nothing but, my dear friends, it is sum of the squares of all the entries of the matrix. So here, dear students, so he is saying A transpose into A is 6, means sum of the squares must be 6. So what entry should I take? You can take 6 ones, correct friends, because the entries must be -1, 6 ones you can take, am I correct? And 3 zeros I can take, am I correct? So in this case, if you take the entries, you see 6 places ones, 3 places zeros. So select 6 out of 9 places, 9C6. There you can write 1 or -1, 2 possibilities, and the remaining 3 places you have to put 0. So these many matrices will be there where the sum of the squares is equal to 6 with entries 1. Second possibility, dear students, there may be, if you introduce 2, 1, 2, 2 is not there, right? So what are the other possibilities? 2 is not there, all entries must be -1, 0, 1 only. So can we make any entry 1, 2? No. 3? No. So this is the only possibility we are going to get, dear students. Accordingly, you can answer this question. 6 ones must be 3 zeros, no other way, dear students. Okay. Next, dear students, transpose related questions. So transpose related questions in the sense, you know well, how to find transpose of a matrix. After that, what do you mean by, A transpose and A, if you observe, you see the point is, so with the help of A transpose we define symmetric, skew-symmetric, orthogonal matrix. But of course here, you see, let us see some questions based on just transpose. You see, this is a familiar matrix. Do you remember cos theta sin theta minus cos theta sin theta? Definitely this is going to be, dear students, a special matrix. A is given, Q matrix is PA P transpose, and P transpose Q power 2007 P is ABCD. Then find this. So finally you need to find Q power 2007. So first you try to find Q square, my dear friends. Q square is going to be PA P transpose into PA P transpose. P transpose into P, my dear friends. I told you one point, this is A alpha kind of matrix. cos alpha sin alpha minus tan alpha cos alpha, its transpose will act as its inverse. So A alpha into A transpose will become I, my dear friends. So this becomes P A square P transpose. Similarly, if you take Q cube, you will get P A square P transpose into P A P transpose. This becomes I P A cube P transpose. So from this induction, you can write, my dear friends, Q power, I can write, I want Q power 2007, this become P A power 2007 P transpose you will get. But finally, I want P transpose should be multiplied here on the left and P on right. Here also you multiply P transpose into P, which will become I. So finally he is expecting to find A power 2007, right? A power 2007, my dear friends. So finally this is A matrix. A power 2007 means A square A cube you have to do. By induction you need to find A power 2007 finally. You see, just find its square, my dear friends. 1101 into 1101. I told you a matrix of this kind, these entries will be 101 on here, and this element, so this is 1 plus 1 will become 2. This is A square. You just observe A cube. What will you get? A cube 1101. You can get, this is 101 will be first row, second column, 1 plus 2 will become 3. So A cube you will get 3. A power 2007 you will get here 101 2007. So dear friends, in this matrix now this is 1, this is 0, this is 1, this is going to be 2007. Now 2A is 2 plus B is 2007 minus 3C is 0 minus 4D is minus 4. 2005 will be the answer. 2005 will be the answer. Okay, dear students. Next, you see this question, A be a square matrix. So exclusive transpose related question. A be a square matrix such that A into A transpose is I. Then he is asking us to simplify this. Array, here A into A transpose I means, I told you, in matrices if PQ is I, QP is also I, that means they commute. So if commutative law satisfies, simplification can be regular simplification, like it is like A plus B whole square plus A minus B whole square 2 into A square plus B square you can write. Got it, dear students? Yeah, so 2 can be cancelled with half. This becomes A cube plus A into A transpose into A transpose. A into A transpose is I, so you will get, dear students, A cube plus A transpose. Option D is the right answer. Okay, dear students. Then some problems exclusively related to symmetric and skew-symmetric matrix is another area. So you know, dear students, symmetric matrix means A transpose is equal to A. Skew-symmetric transpose means A transpose is minus A. Correct? Then orthogonal matrix means A into A transpose is equal to I. Right? And every square matrix A can be written as sum of a symmetric matrix and skew-symmetric matrix, dear friends. This is an important result which is helpful for certain questions. So these points are enough for symmetric, skew-symmetric matrices. Then let us take up the questions. You see this question, dear students. A, B, C are 3 by 3 matrices such that A is symmetric. Okay, A transpose is A, and B, C are skew-symmetric matrices. That is, B transpose is minus B, C transpose is minus C. Now he is asking to check whether this matrix is symmetric or not. So statement 1 true, statement 2 true, he is asking. So symmetric, if you want to check, consider its A power 13 B power 26 minus B power 26 A power 13 whole transpose you consider. If you get the same symmetric, minus of that skew symmetric, so it sometimes need not be symmetric, I mean neither symmetric nor skew symmetric also. You know, dear friends, transpose properties. A minus B whole transpose you can write A power 13 B power 26 transpose, A transpose minus B transpose, you can write. You know, AB whole transpose property is, you can write B transpose into A transpose, right? So dear students, this becomes A 13 times B 26 times, if you multiply from that side, B transpose into B transpose into B transpose 26 times, A transpose into 13 times, okay, minus the same here, A transpose into 13 times into B transpose into 26 times. So that B transpose will become minus B 26 times. This becomes even number of times, this is B power 26 and this is A transpose is A itself, A power 13 minus this is A power 13, you can write B transpose 26 times. So B minus B is multiplied 26 times. So you will get B power 26 only, which is, my dear friends, some matrix transpose you got minus of that. So this is a skew-symmetric matrix, but he said it is symmetric, so this statement is wrong. Same logic you can try with this. So what happens is, minus is there, here A power even is fine, so C power 13. Same logic, what C is, I mean to say, dear students, minus C transpose comes first, that is odd number of times. Here minus comes, minus C power 13 A power 26. This becomes minus of minus plus A power 26 C power 13 you will get. That means same matrix you will get. So this is symmetric, correct. So statement 2 alone is the right answer. Okay, dear students, right. So inverse of a matrix, you know, inverse related simple properties, you know how to find A inverse. So of course finding adjoint A, det A, you know it. Suppose the questions may be given like this, my dear friends. So A is given, A inverse kind of a matrix is given. So friends, if a matrix A, B, C, D is given, 2 by 2 matrix, its inverse is 1 by AD minus BC into its adjoint will become DA minus B minus C. This is going to be its inverse, my dear friends. This A inverse is alpha A plus beta I. Since it is a 2 by 2, you can do like this, my dear friends. Determinant is 1 by 10 minus 5 lambda into 10 here, 1 here, minus 5 minus lambda is equal to A alpha plus beta I. A alpha means this is alpha, 5 alpha, lambda alpha, this is 10 alpha. Plus beta I means you need to add beta 0, 0 beta, that beta will be added here and here. These two are equal, dear students. So if you equate these two, you will get alpha value minus 1. He wants alpha, beta, lambda value, alpha value minus 1. If you equate these two, if alpha is minus 1, lambda is okay, we don't get anything. But alpha plus beta is 10, so beta must be 11, dear students. Okay, then 10 alpha plus beta is 1, am I correct? 10 alpha is minus 10, beta is 11, that is also correct. Now what about, of course dear students, we forgot this expression here, this is also there. So I mean to say, this is minus 5 by 10 minus 5 lambda is equal to 5 alpha, for your kind information. So this element we shouldn't forget. So if you cancel this, you will get minus 1 is alpha into 2 minus lambda. This is the condition. So from which you will get, yeah, so 2 alpha plus alpha lambda. Lambda alpha is equal to 2 alpha plus 1. This is a condition in lambda and alpha. Second point, here also, you see this is 1. So you can say 1 by 10 minus 5 lambda is equal to 10 alpha plus lambda. You see 3 simple equations and 3 variables you can solve, you will get alpha value, beta value, lambda value and simplify. That's it, nothing special in this. You just write inverse of a 2 by 2 matrix directly and compare. Okay, and another way is also there, my dear friend. and he also given alpha plus beta is minus 2 here. So, you can also use that data here to simplify. Or another way is characteristic equation. For the same question, I think, dear students, so you can also write characteristic equation means every square matrix satisfies its characteristic equation. That is A minus lambda I det is equal to 0. If you apply this, you will get a characteristic equation of A. Square matrix satisfies that. For example, here already lambda is there, so let me use mu. A minus mu I det is equal to 0, dear students. Okay. Now, suppose this becomes det of here 1 minus mu, here 5, here lambda, this is 10 minus mu is equal to 0. You just multiply mu minus 1 into mu minus 10 minus 5 lambda equal to 0, which gives, my dear friends, mu square minus 11 mu plus 10 minus 5 lambda equal to 0. Here mu is the variable, so in place of mu you can write A. So, A square minus 11A plus 10 minus 5 lambda into I equal to 0. Now, if A inverse exists, multiply with A inverse, you will get this is A, this is 11I plus 10 minus 5 lambda into A inverse is equal to 0. So, now you want A inverse is equal to, you can simplify, my dear friends, A inverse is equal to 1 by 5 lambda minus 10 into A, okay, minus 11 by 5 lambda minus 10 into I. This is the point. So, from here, my dear friends, alpha plus beta is minus 2. You just equate these two. This is alpha, this is beta, that is 1 minus 11, that is minus 10 by 5 lambda minus 10. This value is minus 2. From this you got, yeah, this is 5 is equal to, you can write 5 lambda minus 10, correct. So, you can cancel 5, 1 is equal to lambda minus 2, lambda is equal to 3, my dear friends. Once you know lambda is 3, 15 minus 10, which is 5, so 1 by 5, alpha is 1 by 5 and beta also we can substitute minus 11 by 5, this is minus 11 by 5, you can substitute, you will get the answer. Okay, dear students. So, that is another method to solve this question. Next, yeah, so all these questions are related to exclusive matrices. I didn't apply anywhere the points related to determinants, adjoint, system of equations and all, right, dear students. Now, problems related to determinants. You see, in matrices and determinants together, certain points related to determinants, you know already about determinants kind of points and results. You see, A is a matrix given, you want, you see, the determinant of this matrix. So, if you take A power 2014 common, you will get A square minus 2A minus I. This is the matrix. Okay. So, you want determinant of this, So, this is det of A power 2014 into det of A square minus 2A minus I. So, this is det A power 2014 into det of A square minus 2A minus I, correct. Det A is nothing but, you know, here det A minus 4 plus 3 is minus 1, minus 1 power 2014 is 1. Now, this is very easy to compute, A square minus 2A minus I, then you can just simplify, dear students, like mean to say it's a determinants you can find, okay. Det of A square you can find 2A minus I, it's very easy to calculate, you can find the determinant, dear students. So, definitely that number may not be this big, you just find A square, dear students, this is minus 4 minus 1 3 1 minus 4 minus 1 3 1, you just multiply first row first column, yeah, this is 16 minus 3 which is 13 and this is 4 minus 1, 3, minus 12 plus 3, minus 9. This is minus 3 plus 1, minus 2. This is a square. The next minus 2a means you just write minus 2 into a, 8, 2, minus 6, minus 2. And I means minus I means you write minus 1, 0, 0, minus 1. You just simplify, dear students. 13 plus 8, 21 minus 1, 20 this is. And this is 9, 5 plus 2, 5 here. This is minus 9, minus 6, minus 15 here. The next minus 4, minus 1, minus 5 here. So this is 100 plus 75. Minus 25 is the answer, which is given option D. That too, here big numbers will not come. 2014, 2016 you will not get, you can observe, but anyhow this is the point which we have to do. So dear students, here determinant of this means simple properties of determinants are definitely necessary, dear students. The next you see this question, A is given, A cube is given where I is the identity matrix, then 2A plus 3b. You see a 3 by 3 matrix, whenever you see this equation, just recall characteristic equation. Every square matrix satisfies its characteristic equation, det of A minus lambda I is equal to 0. That means, dear students, consider det of A minus lambda I means 2 minus lambda A 0, 1, 3 minus lambda 1, 0, 5 B minus lambda is equal to 0. Now you just expand this determinant, 2 minus lambda into 3 minus lambda into B minus lambda this is, okay. So this has given already, so you can say he is asking here to find 2a and 3b. You can just simplify, actually a square coefficient is going to be, you see, a cube minus 4a square, minus 4 is going to be the determinant part. You can simplify this, this is lambda minus 3 into lambda minus b minus a into, you can write this is going to be b minus lambda minus 0, okay. This is the one equal to 0. You just multiply, dear students. You can take that side, lambda minus 2 into lambda minus 3 into lambda minus b is equal to a into lambda minus b. Am I correct? So lambda minus b is a common one, don't cancel. Yeah, here this is going to be lambda minus b into, you can write the other part, lambda minus 2 into lambda minus 3, you will get lambda square minus 5 lambda plus 6 it is, and minus a, this is going to be. So you can multiply here, my dear friends, lambda cube minus 5 lambda square plus 6 minus a into lambda minus b lambda square here plus 5b lambda minus b into 6 minus a equal to 0. Now you just simplify, my dear friends. You got like lambda cube minus of 5 plus b into lambda square plus 6 minus a plus 5b into lambda minus, yeah, ab minus 6b plus ab minus 6b is equal to 0. From this, my dear friends, you just observe a cube is fine, characteristic equation, a square coefficient 5 plus b is nothing but 4. So b must be minus 1 first of all, okay. The next a coefficient, this is lambda coefficient, 6 minus a plus 5b is going to be 1. Already you got b is minus 1, so minus 5, take that side, 6 gets cancelled, a is equal to 0, my dear friends, a is equal to 0. It is enough to find the answer, dear students, 2a plus 3b, okay. 3b is going to be minus 3. You just check the calculation, accordingly you will get a value, b value and everything, dear students, okay. Just check the calculation and accordingly you can do this question. And especially where a 3 by 3 matrix is given, if you get a cubic equation, dear students, mostly it is going to be, yeah. So moreover, you can also say in a characteristic equation, generally my dear friends, if it is like a cube minus, that means lambda cube minus some lambda square term, constant term. This lambda square coefficient is nothing but the trace of the matrix, that is going to be 2 plus 3 plus b is going to be the a square coefficient, that is 4 value. So this is 5 plus b is equal to 4. So b is the same you got here, dear students. So b is minus 1, perfect. So b is minus 1 and a value you just compute. Similarly, the determinant is going to give you the last one, 21. If you directly find the determinant and equate to that minus of 21, you will get b value also, dear students. Next, and most important, properties of adjoint A, cofactor A inverse, det A, in the sense, very important point is det of Ka. If K is a number, A is a matrix, K power n into det A. This is very important. Then det of adjoint A is det A to the power of n minus 1, where n is the order of the matrix. Then det of adjoint A is going to be det A to the power of n minus 1 whole square, and det of adjoint of, like that r times it is given, dear students, det A to the power of n minus 1 whole power r, and you will get adjoint of AB will become adjoint B into adjoint A, most important results. And moreover, det AB you can anyhow know, you can write adjoint A, det A into det B. And another important result is A in the base result, A into adjoint A is equal to adjoint A into A is det A into I, from which we get most of the properties, dear students. And det of A inverse is nothing but 1 by det A. These properties will definitely help us to answer the questions from which we got a good number of questions. Around 40 questions are there based on this concept, dear students. Now let us see those questions, few of those questions. You see this question, let A be a 3 by 3 matrix such that, you see, det of adjoint A is 12 power 14. So what is the formula for this? Det A to the power of n minus 1 3 times is there. Det A to the power of n minus 1 cube is 12 power 4. This is det A to the power of 8 is 12 power 4. So det A must be 12 power 4 by 8, 12 power 1 by 2 root 12, dear students, of course plus or minus. Okay. Now det of A inverse into adjoint A. Det AB you can write det A into det B. So det A inverse is 1 by det A, and yeah, det of adjoint A is det A to the power of n minus 1. So you will get det A is the answer, my dear friends. Plus or minus root 12 means plus or minus 2 root 3 is the possibility, dear students. Yeah, simple application of properties. If necessary, repeatedly we apply, we will get the answer, dear students. Next question, you see, AB are two square matrices of order 2. Det A is given, det B is given. I want det of, you see this matrix. So just you need to do properly. This is determinant of det of 5 det A into B. 5 det A into B is determinant, you see, into A square, it is a determinant. Don't confuse. Determinant of, I have written this, again determinant of 5 det A into B. 5 determinant of bracket 5 det A into B, yeah, 5 det A into B, okay, determinant of 5 into det A into B, then A square. You see, simplification, my dear friends. This is a number, first of all, this is a matrix, and it is a 2 by 2 matrix. Det Ka will become k power n into det A, k power 5 det A into B, okay, k power n into det A square you will get. Fine. So, this is again dear students det A is given already 2, this is 10b. Det 10b means det Ka k power n into det A whole square, this is into det A square you can write det A whole square, which becomes det B is already given as 300, this is 300 square into det A square is 2 square, 3 square, this is 100 square means 2 square into 2 square into 5 square into 2 square. So, that finally 2 power 4 into 3 square into 5 square. This is what he has given, like 2 power A, 3 power B, 5 power C, A4, B2, C2. So, he is asking A plus B plus C, 8 would be the answer. You just simplify again in understanding the questions here. So, you can just see here dear students, determinant of, this is det of, you see det of 5 into det A into B, det A is to det 10b, det 10b means 10 power n, you see det 10b means first of all you can write here like det of, this is the number into A square, det Ka is nothing but k power n into det A, and this is inside of this is det A is to 10b, 10b is determinant, det Ka means k power n into det A whole square is there, this is 10 power 4 dear friends. Here we have gone wrong, you can write this is 10 power 4, this is into, because this is square now, into det B square is 3 square into det A square is 2 square. So, this is you can write 2 power 4 into 5 power 4, 2 power 4 into 5 power 4 into 3 square into 2 square. So, 2 power is 6, 4, 2, 12 is the answer, right. That is the thing dear students. Next, property based questions, there are more than 40 questions out of 200. So, please focus in this area, this is very important area dear students. A is a 3 by 3 matrix and det A is 2. I just want to find det of adjoint of 3 det A into this. You see this students, 3 into adjoint of this. Can you simplify this? Determinant of 3 times adjoint of a matrix. What is this matrix? Det 3A is a number into A square, this is adjoint of this. Okay. First of all, you try to simplify, det A is given as 2. What can you say about det 3A? Det 3A is nothing but 3 power n, it is a matrix of order 3, 3 power n into det A, this is 3 cube into det A is 3, which is 3 power 4, right. This is 3 power 4, this is det of 3 into adjoint of 3 power 4 A square, okay. Now, so this is det Ka will become k power n into det A, adjoint of 3 power 4 A square, right. Det of adjoint A is det A power n minus 1. So, this you can write 3 cube into det of adjoint A, det A means det of 3 power 4 A square power n minus 1, which is 2, okay, which is 3 cube into 3. Now, det Ka, k power n, 3 power 4 whole cube 3 power 12 into det A square whole square is there. So, that this becomes 24 plus 3, 3 power 27 into det A power 4, which is 2 power 4. Yeah. So, which is going to be, you can write 6 power, you see 3 power 10, 6 means if you take 3 that side, you will get 3 power, you are going to get big number 6, you see here 6 power 10 into this he has given 3 power 11. So, 2's again you just check here, So you can write det A is there already. Again det 3A you can write. Once again you see det 3A into A square. Det 3A is 3 power n into det A, 3 cube into det A, and det A is given as 2. Det A is given as 2. Okay, 3 cube into 2 this is. So this becomes, dear students, here we got wrong. So we can do one thing here, dear students. Yeah, simple, because just applying the properties, this is det of K A. What can you write? K power n into det A, det of adjoint of det 3A into A square. Okay, det of Ka is K power n into det A. That is fine. 3 cube into det of adjoint of, what is this number? Det Ka is K power n into det A is 2 into A square, this is, which is 3 cube into det of adjoint of, this is 3 cube into 2. Yeah, I mean to say you can write det of adjoint A as, det of adjoint A, what can we write? Det A to the power of n minus 1, det of 3 cube into 2 into A square power n minus 1 is 2. Now again 3 cube into, it is like det Ka, you can write K power n into det A square, is this det whole square is there. So you will get here, now 3 cube is there. So this becomes 3 power 9, 3 power 18, you just see det A square is det A whole square. This becomes 3 cube into 3 power 9 into 2 cube into det A whole square. Det A is already 2, which is 2 square whole square. Now you will get 3 power 18 plus 3, 3 power 21. 2 power 5 into 2, 2 power 10. So if you want to give 6, you just give 2 power 10 here, 6 power 10 into 3 power 11, option A is the right answer. You just see, this is, you just give 3 power 10 to this, 3 power 11 into 6 power 10. You just need to apply the 3-4 properties repeatedly, that's it. That is the answer, dear students. The next, coming to system of equations, homogeneous system of equations, non-homogeneous system of equations. If the set of matrices is like Ax is equal to 0 given, so if, dear students, det A not equal to 0, it will have unique solution, and that is 0 0 0, called a trivial solution. If det A is equal to 0, dear student, this system will have a solution. Other than 0 0, it will have many solutions, called infinitely many solutions. So if a homogeneous system of equations is given, in that case, dear students, a homogeneous system of equations has non-trivial solution or infinitely many solution, the conclusion is det A is equal to 0. If you want to solve, you can also take the other methods or rank method, dear students. You see here, this question, you see homogeneous system, but comparatively non-homogeneous system of equations has many questions when compared to homogeneous. But anyhow, S be the set of our integer solutions xyz of the system of equations like this, such that x square plus y square plus z square is between 15 and 150, then the number of elements in the set S. So dear student, this is homogeneous system of equations. How to solve, dear students? But you need to find x value, y value, z value. So better we can take the method of rank. So like you see, you can take 1, minus 2, 5, this is minus 2, 4, 1, minus 7, 14, 9. So like augmented matrix, the other one is 0 0 0. You just apply row operation to make this is 0. R2 I change as twice of R1 plus R2, double and add 0, double and add 0, double and add 11. So into 7 and add 0, into 7 and add 0, this is 35. You can say this is going to be minus 2, 4, 1, minus 7, 14, 9, correct. So multiply this with 7, 35, so 44, right? So dear students, this means the equations are like, first equation is x minus 2y plus 5z equal to 0, second equation 11z is equal to 0, third equation 44z is equal to 0. That means the next possibility is z is equal to 0. Z must be 0, my dear friends. If z is equal to 0, x is equal to 2y must happen. So can I take the solution set like z coordinate 0, y if I take lambda, x is 2 lambda. Am I correct? For any, you take lambda as any real number that satisfies all the three equations. But I just want x, y, z are integers, set of all integers such that x square plus y square plus z square less than or equal to 150. So its square is 4 lambda square plus lambda square plus 0 square, must be between 15 and 150. So this is 5 lambda square, 3 less than or equal to lambda square less than or equal to, you can say 10. So lambda square value must be, you can write 4, 9. So lambda can be plus or minus 2 plus or minus 3. I just want x, y, z to be integers, need not be positive integers, right dear students? Yeah. So in this case, for lambda, if you put 2, minus 2, 3, minus 3, you will get 4 set of solutions, and the set will contain 4 solutions, my dear friends. So in this way, you can solve this system of homogeneous equation. Next, dear students, you see almost similar question. X is the column matrix x, y, z, and given Px is equal to 0 and x square plus z square, x square plus y square plus z square is 1. P is the matrix given. Now the solution set he is asking contains how many? Almost similar question. Here also you can do the same. So you take the augmented matrix and you can write first row as it is, double the first row and add, this becomes 0, this becomes 4 plus 3 7, 2 minus 4 will become minus 2. Directly subtract R3 minus R1 0, this is 7, this is minus 1, minus 1 will become minus 2. So finally you got two equations only, dear student, that is x plus 2y plus z is equal to 0, 7y minus 2z is equal to 0. The three equations can be simplified to two equations. So here you can do one thing, you put some z is equal to lambda, you put. If you put z is lambda, y is nothing but 2 lambda by 7. If y is 2 lambda by 7, what about x? X is minus 2y minus z. Minus 2y means minus 4 lambda by 7, because this is y, right? Yeah, this is y is 2 lambda by 7, minus 2y will become minus 4 lambda by 7, minus z is minus 7. So minus 11 lambda by 7, this is minus 11 lambda by 7. Okay, and x square plus y square plus z square is equal to 1, he said. So this is 121 lambda square plus 4 lambda square plus, you can write 7 lambda by 7 means 49 lambda square is equal to 49, my dear friends. Yeah. So you will get 121 means 50, 170, 174 lambda square is 49, correct? So lambda square value you will get. He is asking P contains how many? Are there any restriction on x? No. For you can find two lambdas here. Lambda square is 49 by 74 means you will get two possible values for lambda. So for this case, if you put those, you will be getting two solutions. It contains exactly two solutions or more than two solutions, empty set, singleton set. There are two such lambdas are possible. So that means two solutions will be there which satisfy this constraint. Okay, dear students. So this is all about homogeneous system of equations. And finally, dear students, non-homogeneous system of equations. Suppose you know, my dear friends, if Ax is equal to B is given, there are many methods to solve this, like Cramer's method, matrix inversion method, adjoint method, rank method. Generally, yeah. Good morning, good morning. Yeah. So here generally I will be following here kind of Ax is equal to B in the sense, yeah, rank method I will be following. Consider the augmented matrix A by B, dear students. You just convert it to echelon form, like here 0, 0, 0, like A, B, C, D, E, F, L, M, N. The number of non-zero rows you observe, and accordingly observe the rank of A and rank of the complete matrix A by B. If both are equal to 3 number of variables, unique solution. So both are equal but less than 3, this less than 3, infinitely many solutions. If both are not equal, you will have no solution, no solution. We say that the system is inconsistent. So this case is important. So infinitely many solutions, of course unique solution. Now for example, let me do one question for your convenience here. You see, lambda, mu are real numbers. Given the system of equations has infinitely many solutions, find lambda plus 2 mu. Dear students, here, so you can take, the equations in echelon form. I mean to say, you can take, this is a direct question only. Let us try some other question which is comfortable and easy to do. Here you see this question covers that model also. You see the system of equations are given, so various cases he is asking. You see here, dear students, consider the augmented matrix 1, 1, 1, 6, then alpha, beta, 7, 3, 1, 2, 3, 14. Okay, this is the matrix. So for easiness, dear students, since alpha is here, why can't I write Z first? So that means in my solution set Z first, then X, then Y. That is also fine. Yes, definitely you will get a mark. Yes, you will get 60 marks, because the topics which I have chosen are going to cover at least 13 to 14 questions. Okay, so right, and the combinations, subtopics also I will be guiding, so definitely you will get 60 marks. Right. So 1, 7, 3, Z you write first, then 1 alpha 1 here, 1 beta 2 here, 6, 3 and 14 here. Now what you can do is, with the help of first element, you multiply with 7 and subtract 0, alpha minus 7, beta minus 7, 3 minus 42 means minus 39. Am I correct? Then triple and subtract 0, this is 1 minus 3 is minus 2, 2 minus 3 is minus 1, 14 minus 18 you will get minus 4, right dear students. The next, with the help of this element, you have to make this is 0. So what we can do is, 1, 1, 1, 6, you multiply this with minus 2, so that this is minus 2 alpha plus 14, minus 2 beta plus 14, this is minus 2 means 78. This you multiply with alpha minus 7, that is minus 2 alpha plus 14, alpha minus 7 I have multiplied, this becomes 7 minus alpha, this becomes 4 into 7 minus alpha. Okay. Now you subtract, dear students, you will get here 1, 1, 1, 6. This is 0 minus 2 alpha plus 14 minus 2 beta plus 14, 78. If you subtract R2 minus R3, you will get 7 minus 14 is minus 7, minus alpha plus 2 beta, minus alpha plus 2 beta, and this element is, so this is, you are going to get here minus 28, 28 minus 78, which is minus 50, minus 4 alpha. This is the point, dear students. Now you just observe, he said if alpha is equal to beta is equal to 7, the system has no solution. 7 means, you see my dear friends, 28, this is not equal to 0, and what about this? 7 means minus 14, this is going to be minus 14 and plus 14, 0. Here 0, here not equal to 0, the system will have no solution. True, but he is asking not true. Okay. Similarly, next one, alpha is equal to beta and alpha not equal to beta, the system has unique solution. You just check that also. So, alpha is equal to beta and alpha not equal to beta, so that you will get minus 7 plus alpha you will get here, you will get minus 50 minus 4 alpha you got here. If 7 here 0, here not equal to 0, if not equal to 7, this is not equal to 0, definitely the system will have unique solution. This is also true, my dear friends. Yeah. Similarly, for there is a unique point alpha beta on the line for which the system has infinitely many solutions. System has infinitely many solution means this must be 0 and this must be 0, my dear friends. So, this must be 0, the equation you see x minus 2y plus 7 equal to 0. That means you can find this equal to 0, alpha is equal to, you can find a point 50 by minus 4, that is minus 25 by 2. Accordingly, you will get beta and substitute here. If that satisfies, that may be the answer. If that is true, that cannot be the answer because he asked it not true. If that is not true, you can opt that. Even similarly, the third option also, x minus 2y, you see this is x minus 2y plus 7 equal to 0. For every point alpha beta satisfying this means this becomes 0 and the system has infinitely many solutions. This has become 0 and this is equal to 0. This is false, dear students, but every point will not be. So, if it has to infinitely many solutions, there is only one point possible, not infinitely many. This is false, you can go with this. So, dear students, this method, rank method, will help you to answer this question. Moreover, dear students, even in advance also, this content is almost enough to attempt the questions even in advance, right, dear students. Even here also you can answer the question of the same level. Yes, denote the set of all real numbers of lambda such that the system is inconsistent. Inconsistent means no solution. You see here, no solution in the sense you can start with lambda 1 1 1. So, 1 lambda 1 1 and 1 1 lambda and 1. This is the one, dear students. Yeah. So, you have to show that this is, he said that the system has inconsistent. What are the possible values of mod lambda square plus mod lambda he is asking about. You can also try by subtracting lambda here, and you can try, dear students, same kind of simplification will work here. With the help of lambda, you can start lambda 1 1 1. So, multiply this with lambda and subtract 0. So, this is the lambda means lambda square minus lambda. Here also you multiply with lambda, lambda minus 1. This is lambda minus 1. Here also you multiply with lambda and subtract 0, lambda minus 1. So, here lambda square minus 1. This is lambda minus 1. That is a point. The next step, dear students, this is lambda square minus lambda into this. You can interchange these two columns x, y, z you can write. So, lambda 0 0, 1 lambda minus 1 lambda square minus 1, 1 lambda square minus lambda. You see here actually lambda square minus 1 only this is. Then no need to interchange. In that case, dear students, you no need to interchange. Yeah, you can multiply this with, I can say, you can multiply this with lambda plus 1 and subtract. You will get lambda 1 1 1, 0 lambda square minus 1 lambda minus 1 lambda minus 1. I have multiplied with lambda plus 1 and I am subtracting. So, this is lambda plus 1 into lambda square minus 1 minus of lambda minus 1, that is this element, whereas this element is lambda plus 1 I have multiplied. So, lambda square minus 1 minus of lambda minus 1 is this element. So, here, dear student, for inconsistent solution, these two should not be equal. First of all, this must be 0, that not equal to 0. This is 0 in the sense, my dear friends, lambda minus 1 equal to 0, one possibility. Then lambda plus 1 into lambda minus 1, that is lambda square minus 1 is equal to 1, lambda square is equal to 2. So, lambda possibility is 1 and moreover lambda is plus or minus root 2, 3 possibilities you have. But in this case, this should not be 0. This will be 0 when lambda is equal to 1, this both will be 0. But lambda is equal to root 2, this is 1, this is root 2 minus 1. So finally you got mod lambda value root 2, dear students. Root 2 square is 4 plus 2, 6 you will get. That's it. So dear students, I mean to say the topic matrices and determinant is such a wonderful topic, dear students. It's a simple, easy, little bit of formula based and models you see. If you ask me to highlight the important area even in matrices, I say non-homogeneous system of equations. Out of 220 questions, around 40 to 50 questions are from system of non-homogeneous equations and 40 to 50 questions are from properties of determinants, adjoint, inverse of the matrix and all. Focus in these two areas more, then you focus in other areas. Damn sure you can answer at least 1 or 2 questions that are given from this particular topic, dear students. That's all for the day, and please do subscribe to our channel Infinity Learn by Sri Chaitanya. Dear students, here in this series we are going to cover 10 classes altogether, in which 60 minutes into 10 sessions is equal to 60 marks in JEE Main in 2025. I mean to say, which give you mostly 99 percentile in mathematics, dear students. Okay, so that's all. See you. Take care. Bye.